Okay, we are looking at, now that we've known a bunch of ways to count things, we move on to probabilities. First counting, then probabilities, using combinations. And we work with examples. So we have 649, which was a popular lottery. The rules of Lotto 649 is that you must pick 6 numbers from 1 to 49 numbers. If your 6 numbers match, you win. Now, order doesn't matter. So what's the probability of winning? What is the probability of winning? So how many ways can you pick 6 from 49? Does order matter? No, it does not. So that way we can use combinations. So the total number of ways I can choose 6 out of 49 is 49 choose 6, which is about 14 million. And how many ways are there to choose 6 numbers from 6 winning numbers? Right? It's essentially 1, right? So if I have 6 numbers, how many winning numbers are there? Right? How many winning numbers are there? So there's 1, 1, 1, 1, and 1, right? There's only one possibility. So probability is NA over NS. We have NA, which is 1. We have NS, which is about 14 million. So if I buy 14 million different tickets, what's the probability of winning? So if I buy 14 million or just under 14 million different tickets, what's the probability of winning? 100%. If I buy that many different tickets, I'm going to win with certainty. Okay, what is the probability of winning second place? So second prize win occurs when you get 5 out of 6 numbers matched. Now, how many ways are there to win, and what is the probability of winning second place? So once again, the total number of ways is 49 choose 6. About 14 million, just under 14 million, 13,983,000, etc. Now, what is NA? How many ways are there to select 5 out of 6? Well, 5 out of 6 will be winners. How many ways can you choose 5 out of 6 winners? 6 choose 5. I pick 5 winners from 6, but there's how many ways can you choose 1 losing number? So you have to multiply it. You can't just multiply the winning, because for every way to choose that, right, there is 43 possible ways to choose the losing number, right? So if 1, 2, 3, 4, 5 are the winning numbers, let's just pretend, the sixth winning number could be 6, 7, 8, 9, right? I could have 1, 2, 3, 4, 5, 6. I could have 1, 2, 3, 4, 5, 6, 7. 1, 2, 3, 4, 5, 48, etc., etc. There's 43. Choose 1, the remaining numbers. So it's 6 times 43, which is equal to 258. So very still low chance, low probability of even winning second place. All right, so try this out. To win the grand prize in a fundraising draw, you need to match 7 numbers, 1 to 27, without regard to order. So, fundraising draw, you need to match 7 numbers from 1 to 27 without. What is the percent chance of winning the grand prize? Okay, so how many ways are there to win? Oh, what's that? Sorry about that. Must have been, I'm not even going to explain it. Number of ways to select 7 out of 7 winners. There's only one way to do that, which is 7 choose 7. And how many ways are there to select 7 out of 27? 27 choose 7. Okay, so it's 7 choose 7 over 27 choose 7, which is 1 over, pump it into your calculator, 888,000 approximately. B, what is the percent chance of winning second prize? which involves matching 6 of the 7 winning numbers. Well, it's the same as before, right? Number of ways to select 6 out of 7 winners, and then 1 out of 20 losers. So for every winner, you can choose 20 losers, right? And that counts as a way, because this counts all the ways, right? So NS stays the same, 27 choose 7. Then we have 7 choose 6, multiplied by the ways to lose, multiplied by the one losing number. So it's 140 over 88,000. Still low probability. What is the probability of not winning first or second place? Well, that's how we win first place. That's how we win second place. The probability of not winning that, well, the probability of winning grand prize or second prizes, we just add them up, and then we subtract that from 100%. Not first or second is 1 minus probability of first and second, which is a pretty high probability that you're not going to win. Comment on how difficult it is to win lottery prizes. Well, we just did. It is very difficult to win. It is very likely that you're not going to win. Probability of not winning, you're almost certain not to win first or second place. Here's another example. An 8-person student committee is being formed from a group of 22 students. 9 are in the 9th grade and 13 are in the 10th grade. What is the probability that an equal number of 9th and 10th grade students will be chosen? So we have to find the total ways that the students can be chosen, and then find how many ways you can choose an equal number of 9th and 10th grade students. So what is the probability that more 9th than 10th graders will be chosen? Which outcome is more likely? Okay, so let's do A. What is the probability that an equal number of 9th and 10th graders? So we have to forget NS, which is 22 choose 8. We can choose no restrictions. There's 22 students. We're going to form a committee of 8. How many ways can we choose them? And then we say the equal number. So we need 4 on each. How many ways to select 4 students from 9? 9 choose 4. And how many ways are there to select 4 students from 13? 13 choose 4. So 9 choose 4 is 126. 13 choose 4 is 715. And NS 22 choose 8 is, anyway, it works out to 90,000 over 319,000, which works out to 28%. 28% that there will be an equal number of 9th and 10th grade students. What is the probability that more 9th graders than 10th graders will be chosen? So we have NS. How many ways are there to select 5 grade 9 students, right? There is 9 choose 5, and then we'll choose 13 choose 3 10th graders. How many ways are there to select 6 grade 9 students? 6 grade 9 students. Well, add that. 9 choose 6, and then for every way I choose that, there's 13 choose 2 ways to choose the grade 10s. And then finally, 7 grade 9 students. Well, if we choose 7 grade 9s, we have 9 choose 7. Multiply that by 13 choose 1. We only have 1 place. And only 13 ways to choose the grade 10s. And finally, how many ways to select 8 grade 9 students? Well, that's 9 choose 8. Multiplied by 13 choose none. And we add all those up, and we get 43,000. Okay, so what's more likely? 43,065, which is 13%. So which one is more likely? Well, equal from both is 28. More grade 9s and 10s, that's very unlikely, right? Because there's less grade 9 students. So the answer is, that's more likely. It is more likely to have equal number from both grades than to have more grade 9 than 10s, even though there were more cases. All right, let's see if we can work this out. The following board is a Plinko board. Assume that when a ball hits a peg, it lands on a peg directly. Boom. Oops, let's change this color. It lands on the peg directly and directly to the left or right downwards. What is the probability? The ball hits a peg, it lands on a peg directly to the left or right downwards. So if I hit that, I'm going to hit that, or I'm going to hit that with equal likelihood. What is the probability that the ping pong ball lands on C? Well, this is the path problem, right? If we saw earlier, there are 5 possible landing spots, but the probability of landing on each spot is not equal. Is the probability of landing on C still the same? So if we do it like that, right, is it still the same? No. And is the probability of landing on E the same? Of course not. So let's take a look. There are 13 paths, 16 paths to the bottom. How do I know that? Use Pascal's triangle. I have one way to get here and one way to get here. And then one way, I can only go like that, right? Only one path to here. But from here, I can come at this from here, or I can get to this path from here. There's 2 paths, right? Only one path's all the way down here. So that's 1. Over here, there's 3. And of course, we use Pascal's triangle, again, if you see it, etc., etc. And so I marked it all down to the bottom. Now, how many possible paths are there? Well, there's 1 plus 4 plus 6. And how many paths to C? 6. So number of paths to C is 6. Total paths, all those total, which is 6 to the power 6 over 16, which is 3 over 8. Now if I move it, what is the probability I land on C? Let's use Pascal's triangle again. Okay, it becomes, how many total paths are there? Well, there aren't any paths really, right? There's only 4 ways to C, and total paths are over there, 15. So the probability is 4 over 15. Okay, these are your homework questions. Go ahead and feel free to do your homework.